Recording? Yeah. Okay. Ladies and gentlemen, how often do you get the opportunity to talk in such an event as this, an interpreting practice group, about an event that is currently happening? And I'm not talking about a long-term, large-scale event that may be happening, such as a war, a conflict, or the negotiation of a transatlantic treaty. I'm talking about the culmination of a scientific experiment that is happening today. I'm talking about something that has been going on for a decade now and has been finalizing in a matter of hours over the past few hours. So what I'm going to be talking about today is the landing of the Rosetta and Philae probes on a comet known as Churyumov-Gerasimenko, or 67P. Now, how did I first find out about this? Actually, this was months ago. I was checking a website I like to visit, which is known as XKCD, like the letters, XKCD in English. It's a webcomic about science, sarcasm, and by the way, actually, I recommend it. And it mentioned the fact that this probe was out in space, out to land on a comet, and was going to use harpoons to help it land, like literal harpoons that were going to somehow get into the core of the comet and help that probe land on it. I thought that was interesting. Also, there was a bit of a comical note made saying that in order to motivate it to shoot its harpoons fast enough, the comet believed it was trying to kill... the probe thought it was going to try to kill the comet. So that was the joke in this webcomic I was reading. And so this was months ago. But today, I went onto this website, as I do very often, and found a blank page. It was blank. And I was wondering what was going on. And after a while, I saw that there was actually an animated, well, a very, very slowly animated image of the probe landing. This is a drawing, of course. So the probe landing on the comet. This was going to happen over the course of, I think, 8 hours. So that's typical of this webcomic, by the way. It talks about scientific events, usually in a rather humorous way. So this is how I learned that today was a very significant day for science and space exploration. So now, the more serious stuff. This actual landing on a comet. I found out about it via the webcomic and started, becoming interested, and I thought I'd look up some information on this. So this is a mission that started in the 80s, almost 30 years ago, and it's coming to an end today. Actually, I think it's come to an end already. So this is a comet that I mentioned, Churyumov-Gerasimenko 67P, which is about 4 kilometers in length. It's billions of kilometers away from Earth, and it's traveling at a speed of 34,000 miles per hour through space. So the idea was to shoot a probe out of that. The probe is called Rosetta. You may guess where it gets its name from. It's the Rosetta Stone, which allowed us to understand hieroglyphs, the Egyptian writing. And it essentially looks like any other, like a satellite. It's just kind of a big metal, spherical object with wings on the sides, which are solar panels. And it was launched in March of 2004 towards this comet. The lander module that it's carrying is called Philae, and this is what was detached today, I think some 8 hours ago, to land on the actual comet. Philae, the name actually apparently comes from another document similar to the Rosetta Stone that was also written in 3 languages and also allowed us to understand ancient Egyptian writing. Now, here I'd like to make a side note. These names are chosen because they make no reference to current political or religious figures. This is something that astronomers do on purpose. Philae weighs about 100 kilograms, and it carries 10 different instruments. Among these, we have cameras that can operate at temperatures of minus 100 and minus 150 degrees Celsius. We also have a drill that will allow it to drill 25 centimeters beneath the surface of the comet and extract pieces of rocks to analyze in its inbuilt lab. It also has a set of antennae, two which each cover 60 degrees, so for a total of 120 degrees, which allows it to communicate with Earth. And this camera, or these cameras that it has, have a staggering storage capacity of, wait for it, 10 pictures. Now, that may be a bit surprising. Why can it only have 10 digital pictures in its memory? Well, remember, this probe was sent into space 10 years ago. Today, I was listening to a scientist talking about this on the radio, showing it on his phone, and just comparing the fact that his phone could hold thousands of digital pictures, whereas the probe that was sending them can only hold 10. The way it actually works is that, so 10 pictures are saved at a time, then sent to Earth. This takes about half an hour, by the way. They're sent to Earth, and then once we have them, they're deleted from the probe's memory, and then another batch can be taken and sent. So that's essentially what the probe is doing there. Now, the operation I'm describing, the landing, that took place today. And I keep mentioning I hope it took place because it was scheduled to finish at about 5:30, at which point, you probably know, I was on my way here. Like I said, it's a very difficult operation. The Japanese apparently tried a similar one some years ago and failed. And the thing is, this comet that we're talking about has barely any gravity. It's a terribly small object, only 4 kilometers wide. It has 100,000 times less gravity than Earth does. So this makes landing quite tricky. The probe was sent at a staggering speed, again, of 2.5 kilometers an hour. And by the time it's almost landed, it will have only been traveling at a speed of 3.5 kilometers an hour. So that's how much acceleration that very small amount of gravity will have made for. And the risk is that this landing module probe may actually bounce off because there's very little gravity to keep it on the comet. This is, by the way, I'm told by scientists, a very different approach from that used by the USA. The USA essentially crash their probes into comets because, as I realize, I've forgotten to mention this. This is a European Space Agency project. So the European approach apparently is quite different from the American one. So if all this weren't enough about concerning the difficulty of the operation, it was reported, I think this morning, that there was a problem with one of the thrusters. This is precisely the thruster that was supposed to keep the probe on the comet once it had landed. Apparently, it failed which doesn't function, failed to work. So they're going to have to work for this landing with only harpoons and screws that are underneath the feet of the probe, and they're going to have to screw themselves into the rock or ice that it will be landing on. Now, just a few questions before I finish. Why was this particular comet chosen? Well, apparently this one belongs to the Jupiter family of comets, which means it, if I understand correctly, orbits the Sun at more or less the same distance that Jupiter does. And the advantage with this type of comet is that there are many of them. So if the scientists missed this one, they might have been able to carry on and land on a further one, on another one. And finally, and I think I've actually mentioned this, why was this whole experiment going on? What's the idea? Apparently to gather a whole set of data which could be tremendously useful, but I guess the ultimate implications are very far off because none of it sounds tremendously exciting to me just now. But one thing they're going to be able to do, hopefully, is to evaluate the density and the structure of this comet. Because, and bear with me, hold on, apparently scientists had previously believed that such a body would have a density of 1. Essentially they thought, you just mash some dirt and ice and what have you together, and that should have more or less a density of 1. But new calculations have revealed that the density of this object is expected to be of something between 0.2 and 0.8. So apparently the explanation would be that it's very porous, essentially that it's full of holes. So this is something they're going to find out. And where it becomes important is the following. Apparently, if they can understand its internal structure, they can understand how it was formed. And this comet is one of the oldest bodies that's hurtling around the universe. So if they can understand how it was formed, then they can understand the origin of our solar system and of other solar systems. So at the end of the day, perhaps it is something quite significant. And the other thing they're hoping to find are organic molecules, which, is something surprising because I thought this only could be found in places where there is life. But apparently what scientists are realizing is that there are many more organic molecules. I think organic means it has a lot of carbon in it. There are many more such molecules in space than was previously believed. And this, ladies and gentlemen, may help us explain why we have life on Earth one day. I think I'll wrap up here, but that was an interesting start to my day. I just logged onto a webcomic I like to see and ended up this evening talking about the origins of the solar system and of life on Earth. Thank you very much for your attention.